We've looked at probability, we've looked at counting techniques, and now we're going to use the two together. So let's remember the probability of an event is equal to the number of ways it'll happen divided by the total possibilities. So let's say we have a psychologist who claims that she can teach 4-year-old children to spell 3-letter words very quickly. To test her, one of her students was given cards with the letters A, C, D, K, and T on them and told to spell cat. What is the probability that that child spelled cat just by random? So let's think how that would set up. What are the total possibilities? So the sample space, the number in the sample space, that total. Well, they're only given 5 cards and have to pick 3. So that's going to be 5. Now, does the order matter? It does. The order of those letters matter. So this is not a combination. This is a permutation. So this is being very picky about order. So it's 5p3. So that's under math, probability. It's the second option, and we're doing 5, pick 3. And so there's 60 ways that those 5 letters could be arranged in groups of 3s. And how many ways can we spell cat? One way. So the probability of getting a cat out of those 5 letters is 1 out of 60. Because there's only one way to spell cat. Okay, what about license plates? Suppose that the state issues license plates with 3 letters followed by 3 digits, and that there are 12 3-letter words that are not permitted. Guess what some of those are. If all possible plates are produced and a plate is selected at random, what is the probability that the plate is unacceptable? So we're looking for the probability of being unacceptable. Probability of unacceptable. Well, first let's think about what the total sample size is. So how would we find that? Well, so the first 3 are letters. So there's 26 letters, 26 letters, 26 letters. And then we have 3 digits. So that'd be times 10 times 10 times 10. So whatever that is, 26 times 26 times 26 times 10 times 10 times 10. Woo! There's a lot of combinations. 1,700,000. Whoa, no, that's not 1 million. That's 17,576,000. I almost put my comma in the wrong place. Now let's think about the number that are unacceptable. Okay, so there's 12 3-letter words. They didn't tell us what they are, but they've got them written down. So let's see how we would figure out those 12 3-letter words. I'm sorry, we're not having to figure out those 3-letter words. Somebody's already written them down. We want to know the number of plates that can be made with those 3-letter words. So there's 12 of those 3-letter words times, they'll still have the 3 digits at the end. 10 times 10 times 10. Aha. So that would give me 12,000 ways to have those 3-letter words on a license plate. So 12,000 out of that 17,576,000 options. So that's the probability of finding a plate that is unacceptable. Prior to wireless keys, General Motors keys had 6 parts with 3 patterns for each part, plus an electronic chip containing a code from 1 to 15. What is the probability that one of these keys selected at random would start a GM car requiring a key of this type? So each of the 6 parts have 3 patterns. Okay, so we got 3 times 3 times 3 times 3 times 3 times 3, and then a code from 1 to 15, so there's 15 options there. That's really 3 to the 6th. I'm going to save myself some time. Times 15 gives me 10,935 combinations. And if we're picking one at random, then that's 1 out of those combinations. Suppose that of the 20 prospective jurors for a trial, 11 favor the death penalty and 8 do not. If 12 jurors are chosen at random from these 20, what is the probability that 7 of the jurors will favor the death penalty? So we want to figure out the probability of 7 out of 12 favor. Okay, so if 7 favor, then 5 do not, right? So let's see. We had 12 that favored the death penalty. So we're trying to see what the chance is of getting, so we would have 12, and we don't care what order, we're choosing 7 of those. And then we would need 5 that don't want it, and there were only 8 to choose from there. 8, choose 5. And this is just going to give me the ways that we could pick them. So this is the probability of the event, this first part. The number of ways. And then we also need the number of totals. Okay. The total, we're picking 12 random people out of the 20. So that would just be 20, choose 12. So up here, we would have math, choosing 12, choose 7, arrow over, times, being choosy, 8, choose 5, and we get 44,352. And then the total ways of just picking 12 random people out of 20 is 20, choose 12. That's 125,970 ways. So the probability is going to be that 44,352 divided by the total possible ways of selecting. And we get 0.352. A manufacturing process for computer chips is such that 5 out of 100 chips are defective. If 10 chips are chosen at random from a box containing 100 chips, what is the probability that none of the chips are defective? So let's think how that would set up. Okay, so the probability that all 10 are good. So how many good ones do we have? Well, 5 out of 100, so 95 choose 10 good ones. But we're picking 10 out of 100. And we can actually do this as a fraction, by the way, and do it in one step. and we get 0.584. Now what about having 8 that are good and 2 that are defective? So probability of 8 good and 2 defective. So good ones, there's 95 total good ones. We want to choose 8 of those. There's 5 bad ones and we only want to choose 2 of those. Out of our total 100, choose 10. So I'm going to go up here and just copy that, and I'm going to edit that numerator and make that an 8 times 5, choose 2, and we get 0.0702.